this is another video about combining like terms, but it's combining like terms that are on the opposite sides of the equal sign. So we have two like terms in this equation here. We have 3x and we have 5x. Now, when we combine like terms that are on opposite sides of the equal sign, we do it a slightly different way. Now, the goal, really, in solving an equation is to get the variable on one side of the equal sign and one number on the other side of the equal sign. So x equals whatever number it equals. So in order to move things to the other side of the equal sign, you have to remove them from this side and put them on the other side. So in order to take this away from this side of the equation, you would have to subtract it, because the 3x minus 3x equals 0. This is basically like saying, okay, 3 times 2 minus 3 times 2, it's 6 minus 6, and that equals 0. So this, on this side, it would equal 0. But since these two things over here, the 3x plus 2 is equal to 5x, you can't just change one side and not change the other side, because then they're not going to be equal anymore. So if you're going to subtract 3x from one side of your equation, in order to keep it equal to the other side, you have to perform the same operation. So minus 3x on this side of the equal sign also. So then I do like a big equal sign down here. That means equal, just like that. And so this is 0, so I'm just going to write 0, I guess. You don't really have to, but I'm going to. Plus 2 equals, now that's 5 minus 3, remembering what we did from our other video in combining like terms. 5 minus 3 is just 2, so 2x. Okay, so I'm just going to go ahead and solve the rest of the equation. This one might look somewhat obvious to some of you, but I'm going to just show you how to do it anyways. So let's just turn this into 2, because 0 plus 2 is just 2, so we're simplifying it down, equals 2 times x. Now, when you're solving for x in any equation, when you're solving for x, the way to solve for x is to perform the operation that is the opposite of what x is doing right now. So that's called the inverse operation. Inverse means opposite. So right now, x is being multiplied by 2. And the opposite of being multiplied by 2 would be to be divided by 2, because division is opposite of multiplication. So just like we did over here, where we had to do the same thing on both sides of the equation to keep them equal, we have to do the same thing to these two sides of the equation. So I want x to be all by itself. So if x is being multiplied by 2, then to solve for x, I'm going to divide by 2. And I'm using the fraction notation for division, because that's how you do it with algebra. That's just, well, that's how I do it. That's how I was taught, and I think that's a pretty general way, but it means 2x divided by 2. So you're going to divide by 2 on both sides. Now, over here, 2 divided by 2, well, that just equals 1. And here, 2 divided by 2 also equals 1. And so that equals 1x. And 1 times anything just equals that thing. So 1 times x is just going to equal x. Whatever x is, if you multiply it by 1, it's still going to be x. So this just is 1 equals x. Now, so we have solved the equation. 1 equal x equals 1. You can put it in there to make sure it's true. 3 times 1 plus 2 equals 5 times 1. And that's 3 plus 2 equals 5, which, yes, 5 equals 5. Okay, now that one was a simple one, but when they get more complicated, like let's say x equaled 1.2, it's going to be hard. A lot of you guys try to guess what x is going to be, and you just put it in, keep putting in numbers for x to see what it would be. But there's an infinite number of numbers, so that's not a very effective way of solving for x. You have to know how to get down to it. So what I was going to show you, just kind of why this works, why you don't have to, you kind of ignore the x when you're dividing 2 and 2. So let's say, let's just throw out another example. Let's say you have 4x divided by 2. Well, you're just going to do 4 divided by 2, and so that equals 2x. Now, I'm going to try and what I did with the other video and put a number in there to show why that just equals 2x. So let's just say x equals 5. Okay? Now, we're trying to say that 4x divided by 2 equals 2x. Just to kind of illustrate why I went from 2 divided by 2 down to 1x. So 4x, so then that would be 4 times 5 divided by 2. And that would equal, 4 times 5 is 20, divided by 2 is 10. And to show that it's equal to 2x, 2 times 5 is also equal to 10. So when you're dividing, I know it's, to me it was always confusing as a kid because these aren't like terms, so why should I be able to divide 2 into 2 without even thinking about the x right there? But it works every time. So because of how multiplication works, you just divide the by 2 because I'm having a hard time explaining it. But if I could put in any number for x here, and this 4x divided by 2 will always equal 2x. So when you're doing this operation here, the number next to x divided by a number, you can always just divide those numbers and then keep your x. That was probably way more confusing than it needed to be, so I apologize for that part. But yeah, solving equations, good stuff. Gonna stay with you for years to come and make you extra super smart, and your brain is gonna be all big and huge and overflowing into your ears, out of your ears, and yeah, so yeah,